Hello everyone, welcome back to Alpha Beta Gamma's Ray Optics. This is lesson number 2, and this lesson is about another property of light, which is refraction of light. In this lesson, we are going to discuss refraction, laws of refraction, and some applications of refraction, and also refractive index of a given material. So, what is refraction? Refraction is nothing but the change in the direction of path of light. We know that light is traveling along a straight line. The path of light ray is a straight line, and we indicate the direction of light with an arrow mark. As long as it is transmitted in the same material, in the medium, there will be no change in the path of the light. But when the light changes its material of propagation, when it changes its medium, then the path or the direction of the path will be changed. When light is traveling from one medium to another medium, so let it be medium 1 and medium 2, when it is propagating from 1 into 2, the second medium, after crossing the boundary which separates the two materials, it just bends. The path of the light ray is slightly changed. This is known as refraction of light. So during the refraction of light, there will be a change in the direction of path of the light. What causes this change? Why the path of the light is slightly changed after passing through the second medium? This is due to the change in velocity. Velocity of the light changes with medium. So it changes with the material of propagation through which it is transmitting. Why there is a change in the velocity? This is due to the change in density of the material in which the light is propagating. So due to the change in the density of the material, there will be a change in the velocity of the light. So this is the reason why the path of the light ray is slightly changed, it bends. How does the light ray bend? How the change in direction of the light occurs? It depends whether it is traveling from rarer medium to denser medium, that is the material which is having lesser density to higher density, or from higher dense material to lesser dense material. So the medium which is having less density is known as rarer medium, and the medium or the material which has high density is known as denser medium. So the refraction of light is observed in two cases. Number 1, the light is propagating or the transmitting from rarer medium having less density into the denser medium having more density. For example, light is traveling from air to glass or air to water. And the second case is the light is propagating from denser medium to rarer medium, from the material having more density and propagating into the material having less density. So the example, from water to air or glass to air. In both cases, we can observe the light is bent. It means the direction of path of the light is changed. How does it bend? How does the change occur in the direction? In the first case, when light is traveling from rarer medium to denser medium, and we can draw a normal to the surface. Then light ray bends towards the normal. In the second case, at the boundary, the light ray travels or bends away from the normal. It means when the light is passing from rarer medium to denser medium, after crossing the boundary, after entering into the second medium, the light ray bends towards the normal perpendicular line drawn to the surface of the medium. In the second case, light passing from denser medium to rarer medium, and after entering into the second medium, it bends away. So let us see clearly with a ray diagram which shows the refraction of light. In the first case, the light is traveling from less density material to high density material. Here we have a diagram, and this is air. Suppose this is the medium 1, and this is water. This is the second medium, and the light is traveling from air to water, lesser density to higher density. And this is the surface boundary which separates the two materials, air and water. We can draw the normal to the surface boundary, and the light which incidents on the surface at this point, this is incident light. After crossing the boundary, entering into the water, it bends towards the normal. So it means here the bending is towards the normal, closer to the normal. And we can observe two different angles. Number one, the angle between the normal and incident light, which is called angle of incidence I. And number two, the angle between the normal and the refracted light, which is bent inside the water. This is called angle of refraction R. Here, the bending is towards the normal, so angle of incidence is higher than, greater than angle of refraction. Angle I is greater than angle R. And in the second case, where the light is traveling or transmitting from higher density material into the lower density material, from denser medium to rarer medium. Here we have the diagram. In this diagram, light is propagating, transmitting from higher density, say water, into the rarer medium, lower density material, say air. And where it crosses the two materials, the boundary, we can draw a normal perpendicular line here. So we can clearly observe that light is bending away from the normal here. So in the previous case, light bends towards the normal, but this is the case where the light is traveling from denser medium to rarer medium. Light travels away from the normal. Here also we have two angles. One, angle of incidence between the normal and incident ray, and angle of refraction between the normal and refracted ray. So here in this case, angle of refraction is greater than angle of incidence here. So that in the two cases, there is a change in path of the direction of the light here. But only the difference is we should observe whether the light is traveling from denser to rarer medium or rarer to denser medium. Accordingly, the laws of refraction will be followed. Here we have the laws of refraction. The refraction is exhibited when the light is traveling from one material to another material, from one medium entering into the second medium. It means there is a change in the propagation, there is a change in the material of propagation. The second thing is the angle of refraction is not equal to angle of incidence. And third point to be observed is the incident light, refracted light, and the normal all are in the same plane. So these are the laws of refractions. Angle of incidence and angle of refraction are not equal to each other. In the first case, where the light is propagating from rarer medium to denser medium, angle of incidence is greater than angle of refraction. In the second case, where light is propagating from denser medium to rarer medium, angle of incidence is lesser than angle of refraction. So this is about refraction and where it is applied, where we can observe the refraction in nature or practically where we can use the refraction phenomenon. We have here a few examples of refraction which occur in nature and in practically we can use them. The first and foremost application or the main significant of the refraction of light, as I said, even in the case of reflection also, eye vision power is due to refraction also. Here, so in the eye, the retina will act as the capture or the camera, and in which the light is refracted and forms the image of the object what we see. Here both the reflection and refraction, they are, they are much useful for eye vision. And we have a few more natural examples also phenomenon. Optical illusions like mirages. So we can see an illusion of water shade on the roads during summers. And also at the horizon, when sunset, at the time of sunset, the bottom of the sun appears to be flattened slightly. The sun is spherical in shape, but during sunset, we can see or observe that due to refraction of light, the bottom appears to be flattened here. And also, the apparent depth of the pond or water level is different with the actual depth of the water. These are the natural phenomena so which can be observed due to refraction of light. And also rainbow is formed due to refraction of light. Here rainbow is caused due to total internal reflection also. We will discuss this topic in the next lesson. So, and some more practical applications are there. We use many optical instruments. So, these instruments are manufactured using, constructed using lenses. The lenses form images based on the principle of refraction only. And optical instruments like a magnifying glass and prism, they work on the principle of refraction of light only. So here we can have a few diagrams which explain the applications or the phenomenon of refraction. Here a pencil is dipped in the water of a glass. A part of the pencil is here dipped within the water, and we can observe that there are two images of the pencil. One of the images which is inside the water is somehow different bent. It is due to the refraction of light. So this refraction is from air to water, which bends towards the normal. When you see from the top, the bending of the image is closer to the surface or the normal. When you see from the bottom, we can see the bending is away from the normal. This is due to refraction of light. And we have the second diagram also here, second picture. Here we can see a picture. In this picture, the image, or we can see the fish. Actually, the fish is here. This is the actual depth of the water. But a person is seeing or looking or observing from the bank, from the top here, at an angle of incidence I. And the image of the fish appears to be somehow higher. The position of the fish is somehow higher raised. So this is due to refraction of light here. So the rise of the depth depends upon angle of incidence. And this is another picture which shows the flattening surface of the sun. During sunset, the bottom of the surface is somehow flattened, which is not actually flattened, appears to be flattened due to refraction of light. These are a few examples of refraction of light. Then what is the significance of refraction? And how do we observe the refraction of light in a given material? Here, as I said, when light is transmitting from one material to another material, there is a change in the velocity of the light. In vacuum, the velocity of the light is denoted by c, and the value of c is 3 multiplied by 10 to the power of 8 meters per second. But even in air also, the value of velocity of the light is equal to c. It means the speed of the light is equal in air, almost equal in air and vacuum. In any other material other than these two, the velocity is different, and it depends upon the nature of the material. It depends upon the density of the material. So, the ratio of velocity of light in the vacuum to the velocity of light in a given medium, this is a constant. It's a parameter constant which has no units and dimensions, because both the values in numerator and denominator are velocities. So the units and dimensions are cancelled, and this quantity, physical quantity, is known as refractive index. This index is denoted by a symbol mu. Here we have taken the ratio of the velocity of light in the medium with respect to the velocity of light in the vacuum. So this is known as absolute refractive index of the given material. So this refractive index of the material varies with material, changes with the material. So instead of considering C value, or the light is traveling or propagating from one medium to another medium, then how to calculate the refractive index of the material? Here the refractive index is not absolute refractive index. This refractive index is called relative refractive index. We denote with mu r. Relative refractive index is the material, or a refractive index of the material with respect to the another material. For example, if I write mu to 1, this is the refractive index of the second material with respect to the first material. Refractive index of the second medium with respect to the first medium. Or we can write mu 1, 2. This is refractive index of the first medium with respect to the second medium. Then how to calculate relative refractive index of the given two materials? So if I write mu 2, 1, refractive index of the second material with respect to the first material equals to, here velocity of the light in the first material or the first medium to the velocity of light in the second medium. So we can write in terms of refractive, their indices, individual refractive indices also. Here V, velocity of the light, is here calculated in terms of refractive indices as here C divided by mu 1 whole divided by C divided by mu 2. Then you will have mu 2 1. Refractive index of the second material with respect to the first material will be C will be cancelled. You will have mu 2 divided by mu 1 here. So, refractive index of the second material with respect to the first material is equal to V1 divided by V2, or in terms of their individual refractive indices, mu 2 divided by mu 1. So if I write mu 1 2, refractive index of the first material with respect to the second material, this will be in terms of velocities. Here we have V2 divided by V1, or the ratio of individual indices mu 1 divided by mu 2. This is relative refractive index. Either absolute or relative refractive indices. There is no units and dimensions of refractive index. So this is about refraction of light and the refractive indices. And in the next lesson, we will discuss total internal reflection. Thank you for watching this video.